Hello, welcome to another leaf map tutorial. In this video, I'm going to show you how to access the NASA Opera data products. So first, let me show you what the results looks like. So I'm going to show you how to search the NASA Opera data products interactively, and you saw for example, the footprints on the map. You can also visualize the data, load the data directly without having to download the data. So this one shows you the dynamic water extent, one of the NASA Opera data products, and you can visualize them interactively. You can also download the data. Also, the data products contains multiple data layers. You can select any data you want and then load the data set. So first, let me show you where to get the notebooks. You can go to the leaf map website, and on the left side here, click notebooks, and then scroll down to find number 101 NASA Opera. And from here, you can look at some basic information. So for those of you who are not aware, NASA Opera project basically is an initiative that's creating global data products and also North America data products. And this is very useful. These are some of the existing, some of the data products that already exist. So for example, the near surface water extent and derived based on harmonized Landsat and Sentinel-2 data products, and also it has the Sentinel-1 data products. So this is what we're going to focus today. But there are also some other data products, for example, the surface disturbance, and also some displacement, vertical lane motion, something like that. You can look at the demo in here. Basically shows you what kind of data products that can be useful for different environmental applications. And I'm going to show you in this video how to get access to the surface water extent data products. If you want to learn more about the data products, you can go to here, the product webpage, and select the one that you want. So we're going to click this one, DSWX, and this one shows you the data products. And as you can see from here, it's built on top of the harmonized Landsat Sentinel-2 data products. It also has the Sentinel-1 data products. So if you click here, right now it's only one menu, but if you scroll down, you will see Sentinel-1 data products. So actually it has two different data products, but they both are mapping the surface water extent using the Sentinel-2. And if you want to learn more, for example, what the spatial temporal coverage, you can click the overview page and then scroll down to the end. So this is going to show you, for example, these are the 4 already in production. The DSWX Sentinel-1 is actually already in production. So these are actually the 5 data products already in production. And if you scroll down, for example, we're going to find the surface water extent here. It's available at the 30-meter resolution. So even though Sentinel-2 is 10-meter resolution, but the data product has been resampled to be consistent with Landsat. So it's 30-meter resolution, and it's available from April 2023 onwards. And so we have basically 1.5 years of data availability. In the future, they want to also have NISA and also SWOT data products. So for now, we just have these two. So next, let me show you how to actually look at the data products. So if you go to the DSWX, and I would encourage you to open the the product documentation. So here, if you click the read document, it should take you to the page of the documents. So what we're going to look at here in this tutorial is the data layer. So if you click on the left side, product data layer section 4.1, and this will show you what kind of data products available. So in total, it has 10 different data layers. And the primary one we're going to look at is the water classification. So basically use Landsat and Sentinel-2 to map surface water extent. And so it's basically classify every imagery available, and then it's going to classify into different classes: open water, partial water, snow ice, cloud and cloud shadow, and also ocean mass, and also field value if there's no data. And also the binary basically is combination of 1 and 2. So all the open water and also partial water pixels are combined together as one single data layer. There are also some other one, confidence, and then what else? I think the one will be useful, for example, lane cover classification. So if you need to see, for example, some of the lane cover, because you utilize some of the DEM and also European Space Agency world cover data set, and also the last one, the DEM. So sometimes if you need DEM, you can also look at load the data layer. So all the image types is 3660 pixels, rows and columns. So this is basically the same size. All the images are at the same size. And so next, let's get started. So you can run this one in Google Colab. So if you open the link in Google Colab, then you can install the library. You do need to have a Google a NASA Earth data account in order to download the data. And so you can uncomment this one and then just click this one to run, install all the packages. Then you should be able to follow step by step. So here I'm going to show you in my local Jupyter lab. So first, let's import the libraries. And like I said, there are multiple data products. So for this video, we're just going to look at the dynamic surface water extent data products. So once you import the libraries, you do need to have a NASA Earth data account. So if you don't have one, click the link, and then from here you can register for an account. And once you register, you can run this block. It's going to ask you to enter your username and password. So after you just enter, then you should be good to go. So you're authenticated to connect to the the NASA Earth data database, and then you can just source the data. After that, run this one. So we're going to load the base map, and also we're going to use this one, add NASA Opera. So this one is basically adding the GUI here, allows you to source the data interactively. And the drop down list here, the short name, basically every dataset in the NASA Earth data catalog, they have a short name. So basically a unique ID. Right now we have a total of 4 here. And so the DSWX, basically dynamic surface water extent. DST means the disturbance. And so the first 4 of those basically just the SAR data products, and we're not going to cover in this video. So for this one, we're going to use, for example, the optical, based on the optical data, harmonized Landsat and Sentinel. Or if you want to use the Sentinel-1, the SAR data, you can use this one. So we're going to select the HLS. So here I'm going to show you the description, what it is, the basic description. And when you are searching the data, you can just zoom to anywhere you like. So we're going to zoom to a particular location. For example, here is covering the Las Vegas, right? So the reservoir, and you can zoom to the area that you like. You can also select the date, for example. If you want data for a particular date, especially if you're doing disaster management, you want to figure out compare the differences before and after, then you might want to select this one. So for example, I can select November 1st, 2024. You can set an end date. If you don't set, it's going to be the current day, and then you can just click search. See, so now it returns all the result. So here you can see by default you're going to return 50, maximum 15 data set. So if you scroll down, you will see all of those in here. So this is all the data set that meet the requirement since November. Basically, it's the past month. And then if you have your mouse on the footprint, it's going to show, if you click, then it will show you, for example, some basic metadata about the data set. So, and there's a file name convention here. So all the native ID. So this is basically the unique ID of the data set. So you can take a look at this one, Opera level 3 DSWX, and then HLS. So basically this is about the data products, a different label, and DS surface water HS. And this one basically is the time ID. So every rectangle, every square has a time ID. So using the military grid reference system. So basically the unique ID, kind of like the UTM basically. And after that, you'll be the acquisition date of the imagery that was used to generate the surface water extent. So for this particular data set is 2024, November 14. So it's just 2 weeks ago. And this will be the time, hour, minutes, seconds. If you scroll to the right, so this one shows you basically is the data generation. So that means when was the surface water extent derived, basically the generation, the data production date. And after that, you should be 808, basically Landsat 8, 30-meter resolution, version 1.0, right? So if you scroll, see here, you should be able to see, for example, some of them are 808, basically Landsat 8, Sentinel 2B, Sentinel 2A, and they don't have Sentinel Landsat like 9 right now. So if you click this one, for example, I want to see this reservoir, and one important thing you need to take a look is this one. So this will be the time ID, TLL-SQA. So if you go here, I'm gonna scroll down, and you find SQA, right? So it will be this one. So this will be the dataset covering this area. Then you can select the data layer. So as I showed you earlier, in the Opera data, the dynamic water extent, the data products documentation, it has 10 data layers. So we have the water class, binary water class, confidence, and also, for example, lane cover, DM. So you can select any of those data layer, and all you need to is click this display button. Then it should be able to query and load the data. So right now you can see this is the data set. Actually is not very good because it's probably most of those are cloud or cloud shadow. So like I said, so if you look at this one right now, this is data set, right? So if you load the DM, it's pretty much this is not very useful. So if you want to figure out what this one is about, what's the pixel value, so I can click this one and then you can cover your mouse. So this one is 253. If you go back to the documentation, let me go back to the first class here, 253. So this means it's cloud and cloud shadow, and this is a very low quality image because it's full of cloud coverage. So let me show you here. Then I can reset everything, and oops, let me close here, or maybe one more time. And so right now, if you use the default one, I believe in the 2023, the April, there's pretty good imagery. So again, I'm going to click this one, show you the IDT11 SQA. So I'm going to go back to here. It will be the second one, and then display. You see, this one is pretty good. So let me turn this one off, the footprint. So yeah, indeed, there are also some different like cloud and ice and snow. So let me add all the imagery. So this would be one, right? So it doesn't cover the full coverage, and this would be another one. So this one is SQV and SQV. So load this one, display. Also on the left side, there's also a small portion here. For example, this one, you'll be SPV. So let me find SPV and display. All right, so now we can turn off the footprint to see the result. If you zoom in, it's pretty close. Again, right now, this is just using a Google-based map, but ideally, we want to bring in the whatever data set is being used to derive. So in this case, it's all the Landsat 8 imagery. So in the future, I will create another tutorial showing you how you can bring data from Google Engine, and you can overlay the surface water extent on the imagery that was used to delineate this surface water extent. So clearly, if you zoom in, you can see the pixels. So this is 30-meter resolution data set, and by default, we're using the tab 10 color map, but you can change to something else. Also, you will notice some artifacts in here. So again, these are just the pixel values that's not surface water. And let me turn off this one. If you click this identifier, it should allow you to, for example, click the pixel. Whoops. Looks like there's a bug. Oh, maybe I think there's a bug, so I probably need to something is wrong. Let me restart the section. Not sure what happened. I need to look into that. So let me run this one again, and then load the data set again. So probably some case is still in there, so the layer are not basically reflected. So let me try this one more time. Shows the data set. Okay, and I'm gonna load the SQA data set. So the first one, and then SQV. All right, and then the last one will be SPV. So those are the three data layers that we want to look at it. And let me turn this one off. Okay, so let's try this one again. Hopefully it works. So if I click my mouse, oops. Huh. Interesting. It works yesterday. Okay, now it works. Oh, basically it's just a different data layer. So it should have three data layer. Oh, I think I know the problem because the layer name right now they're all the same. So it's basically the previous one replaced with the existing one. So I probably need to maybe add also the type ID so that it's not all the same. Otherwise, because this is the last one I added, and so it's basically replacing. So right now the data layer, because you're using a unique data layer, that one I need to improve leaf map. But anyway, so if you click, you should see the pixel value. So this is 1, if you go back to this one here, one means it's just open water, partial water, and then the other three values are basically non-water body. On the left side here, clearly, if I click this one, it's 253. So 253 is cloud and cloud shadow. So those are not water, but you might see some other stuff in here. So these are actually water. So number one, and also here, look at the top. This is also 253. Basically just cloud and cloud shadow. So if you're just looking at water, then you'll be looking at this one. So you can also load the binary dataset. Right now, it's only just one of these in here. So if you can, the binary dataset will combine the water and partial water together. So let me close this one. And again, let me open this one. Okay, so earlier we used, for example, just the water class. You can also open this one. I'm going to show you the DM, so I can click the DM and then use it with DM. I want to use the terrain color map, and then just click display. You should be able to load the last one. So basically, you'll be covering the DM covering this area. The DM is a little bit larger, so you're going to take a little bit longer time. So clearly, now you can see the DM loaded covering the same area, and so you can turn this one slide on and off. Again, you can also change other ones. So right now there's a limitation, so we can only select the color map. So hopefully I can add another option that allows you to use a custom color map, but for now we just use the default one. And also, for example, the binary water classification, I mean select, then you only have two classes. So now the water and non-water has been combined together as a single class. So as you can see here, right now, you on the border here, you don't see that anymore. So, but if you combine this one with the previous one, some edge pixels have been combined together as a single class because it's a binary class. Okay, so this is how you can load the data layer easily. You can change different data layer. You can also change it, for example, to the Sentinel-1 data products. And after that, assume that, okay, you're looking at this one and then it covers your area. You want to download this data set. So in the next step, you can use this one, m_NASA data GTF. So you're going to return the entire data frame. So we're going to show you, for example, so this one should a total of 50 data set because we set a maximum of 50. If you scroll down all the way to the end, it should show 49, right? Basically, it's 50 rows, so 50 data set, the entire data frame. So all the data set, the footprint that cover the area has been can be accessed using this geodata frame. Okay, so this is some of the basic information. You can see the date, see the column, unique ID, and also the URL. So if you need to download it, for example, as a geodata frame, then as a shapefile GeoJSON, you can do it easily. Also, for the data layer that have been loaded, you can retrieve this one as an X-ray data set. So for the last one, for example, the last data layer that we loaded to the map. So in this case, it would be the binary data set. So it would be BWTR, right? So if you change to other data layer and then you click display, whichever is the last one you display on the map, you can access that one as an X-ray data set. So in this case, this will be the binary data set, binary water classification. So you can see the bank, basically just one bank, 3,660 rows and the same number of columns. And you can see all the pixel values. So these are basically inside all the pixel values. And once you select the data layer, if you want to save that to your local computer, then we can just save this data set. So under the hood is reading using raster IO, so also a RIO X-array. So what we can do here is to get this data value. So basically this is the binary water classification data, and then RIO, and then to raster, then we can save it to our local computer. So if you click this one, you should save this one to our local computer here under the current directory. So you should see this one, data dswx.tirf. Also, if you want to save all the data set, for example, you want to download all the data set that you have sourced. So this one here can be accessed using this one, NASA, m.nasa data. So this will be the total of 50. You can see all the links. It might be overwhelming. It's not very easy to look at. So this is essentially the Earth access search results. So you have the entire collection. Inside you have all the URL. So for each dataset, it has 10 data layers. So actually a lot. And you probably don't want to use all of them. So for example, you can just show the first one. So with NASA data search result. Again, so this will be the first data set showing up on the list, right? So if you go back to here, you'll be this one. So this will be the first data set. This data set has 10 data layers. So you have 50 data set, you actually have 500 data layers. So you're going to end up with 500 GeoTIFF. But if you, once you select the particular one you want, you can click this one. It will pop up. It will take you to the website, but you need to log in. We can download it automatically. So what you can do here is to, depends on which one you want. So this one shows you in total is 34 megabyte. And so for example, if you just want the first one or the second one, whatever you like, you can, if you want all of them, you can just remove this one and then you download all 50 data set. This is going to take some time. So I'm going to basically, for example, select, let's say I just want the second one, and then you run this one. It should be able to automatically download the dataset. It might take a couple seconds because it needs to download 10 files, 10 data layer for this one. So once it's done, open this. So you should have this. These are the new one that I just downloaded. Those are the one by testing earlier. So for example, this will be, you can see the time here, the modified time. So 10 data layers. And once you have the data layer, you can load it using leaf map, or you can load it using desktop GIS, for example, QGIS or whatever you like, right? So I can show you quickly. Earlier, we just loaded using basically data in the memory, so using X-ray. But once you download it, you can do the same thing. Okay, using leafmap.map. Okay, and then just display the map. So what you can do here, you'll be just m.add raster, and then data. So here, oops, you need to double quotes data, and then you can select whatever data layer you like, right? So we are actually looking at the SPV, probably the second one here, WTR, okay? And you can give a layer name if you want. I can also do a color map, for example, COLOR map equal to tab 10, and then just write it. Okay, so this is the data set. This is a local cloud in here, but oh, this is not the one covering. Oh yeah, covered in here, but it's a different data setting than the one we selected. But you can also load this one, right? So DSWX, this is the one actually we loaded, we downloaded, and we selected it. So you can do it this way. DSWX. Yeah. Or probably because we load different data layers, so that's why it's not exactly what we want. So let me show you maybe one more time. I'm going to maybe, oops, here, right? So for example, I can select the SQA, right? So this will be the second one, and then I select this one. So I'm going to basically display. Okay, so now I have this terrain. So in here, interesting, there's some warnings in here. So once I have this data layer loaded, then I can run this one again. So I'm going to go back to the this one, and if I run again, the map. Okay, there's some error message. DSW. Yeah, it should be. So I'm not sure why. Anyway, so let me try just one last time to rerun the code block. Okay, so I'm going to the search, and then I'm going to select, for example, SQA display. Right, so I have this data layer now, and then I can display here. You should be able to download. Let me run this one. Okay, it works now. So then I can just load this data layer. So again, I'm showing here. That's weird. Oh, because I think under the hood, when doing the display, I automatically remove the background. So that's why the background should not show up. because I do the reclassification. So right now it's showing up in here because it's like no data. Anyway, so you can basically download all the data set you want to your local computer. Then you should be able to visualize and analyze using the data set that you downloaded. In the future, I create another tutorial showing you how to download more data set and mosaic them together, so you can create a raster, mosaic raster that covering a large area. Okay, so that's all for this video. I will see you in the next one. Take care. Bye bye.